This document, if you didn't have a chance to print it out, you can just copy it down on a sheet of paper. But we want to do more KMAP practice today. Last time we were together, we did a 2x4 KMAP. We had 3 variables. We're going to extend it by one variable, and that gives us what we call a 4x4 KMAP. And basically, you do exactly the same thing with the numbering over here. Like you number starting here at 0, so that's 0, 0. And then you'd have a 0, 1. You come down to 1, 0. And then here would be 1, 1. The difference is you have the same numbering along the top. So here you have 0, 0. I'm drawing with my mouse, so it's a little hard. 0, 1. 1, 0 over here. And 1, 1 right there. And then you draw your line up. Your variable A would be here. B. And on this side, you'd have C and D. And so just like before, every cell has a binary value. I mean, the value here in this cell would be 0, 0, 0. This cell would be 0, 0, 0, 1, and so forth. So you should know how to write the binary value in each cell. That's important because the KMAP actually connects to the truth table. And the way you connect to the truth table with the KMAP is by with the binary number for each cell. And I'll show you that on Friday. So what I want to do is practice. Now I see I made a mistake here. It looks like A and B are the same. So I guess we'll just forget about this one. Some kind of way I made a mistake there. So let's try that first KMAP. Make sure you have it numbered the correct way on the top and bottom, and then go ahead and group them. Now remember, you can only have a group that's a power of 2. So you can have a group of 1, a group of 4, and in the previous KMAP, you can have a group of 8, but then you wouldn't have anything left. But here you can have actually a group of 8 up to 16. So you're grouping, and then the other part is that, remember wraparound? If you remember wraparound from our discussion, here you can actually wrap it 2 ways. I can wrap this side with this side, and I can wrap the top with the bottom. So I can fold this 2 ways, this KMAP. So with that in mind, go ahead and see what you can do with the first problem, letter A, and we'll do it in just a second together. So I'll give you a few minutes to get started on it. We can go ahead and set this up with the numbers. The number top the same way. How many groups for this one?
I have 3.
3?
I have 3 as well.
Okay. So I'm assuming you got this one right here, everybody, right? That one.
Yeah, I got that one.
And since that takes out one this way, takes out, well, let me just write A, B, C, D. So I'm going across the whole row. It's going to wipe out C and D because they change. If I check these two, I see that the bit A changes. So I get rid of A. And B is a 1, so I leave it unknotted. But where's the other 2 groups? Which other 2 groups did you have?
I have the top right square for the 2x2.
Okay.
Right.
So he's saying this. Is that the way to think about that?
No, I was including it with the other larger one.
That's right. So remember you want the group, but you want the largest group of members, and you can share members. So he's actually correct. You want this group right here. You can't circle 6 because it's got to be a power of 2, but you can definitely grab that 4 right there. And if I go this way, it looks like D changes. So that's gone. If I go up and down, B changes. So that's out of there. And I see that A is a 0, so I got to knot it. And where's the last group? It's got to be that one, right? So we're gonna, again, you could have a group of 1, but so that you get more variables to drop out, you want the largest number of members in the group. So it's a group of 2 where you share that one. And moving this way, these 2 are going to stay the same, so I got to knot the C. And it's going to be A or B that drops out. You can see that B changes bits. So for that minimized term, we got A, C, not D. I think that's finished. That's the expression. So then what you would do, of course, is set these equal to some variable and just list them out, or each term together. They're always forward together. So that's the way you do that. So all I want to do today is I have 4 prepared for you, but I see that I never went back. I made a mistake gave you 2 of the same problem. So I guess we just will do, we have 3 today. So let's move over to the next problem. We'll skip down to map C and see what you can do with map C. Okay, anybody want to take a shot at this? How many groups?
Are there 3?
Okay. And I'm sure you got this one right here. And again, since we're going all the way across the map, I'm going to lose C and D. And A is a 0, so I got to nod it. But where are the other 2?
The 4th square on the top left.
Exactly. So we're going to use this idea that we can share. We can reuse these members, and then I guess you got the 2 down here. So let's go ahead and just finish this one, and then we'll go to our last one. So I move here. Looks like D is out of there. C is knotted to 0. As I move up and down, B drops out. A is a 0, so I knot it. So I get not A, not C. And then for this one, I'm moving this way, so I'm going to keep A and B. B is 0, so I got to knot it. I'm going to lose either C or D. Looks like D stays in 1 and C drops out. So I get A, B, not D. So not too bad. This is a lot better than trying to solve these Boolean expressions using Boolean algebra, as you'll see. But let's do the last one. Now the last one, be careful on. You got to think about this one.
Is there a 4th one on this one? Sorry.
Wait a minute. Hold on. I'm sorry. Okay.
Is
Ask
there
your
a 4th
question.
one where, like on the bottom grouping, can that wrap around to the top and create another 2?
Right here.
Yep, right there, and then the top check mark. Can that
He
create a
said,
4th?
can we go this way and that way? Yeah. So is that allowed? Why would we not want to do that?
You already have all the checks in groups, so there's no need to add another additional group.
Right.
Oh,
And so
okay.
that's and the idea is, guys, we want the fewest number of groups with the most memory in each group. And we're guaranteed if we do that to get the most minimized term. So we would not want to do that because, as he said, we already have all the members included. So you're just making extra work for yourself. It's not going to benefit you. That is a good question. But I want to get to this last one because often students miss something on this one. So we'll see what you can do with it. Look at map D. See what you can do with map D. Okay, what'd you guys come up with? How many groups?
3.
Okay. All right, so which 3?
You got a group of 8 that wraps around those 2 vertical.
Exactly. Everybody see that? You can wrap it, you can fold it around this way, and fold it around like that. So he's talking about, I got a group here, and I can wrap around with this one. I'm going up and down this way, so I'm going to lose A and B, so I can just get rid of those right away. And then I check my bit values just at these 2 ends. It looks like D stays at 0 and C switches bits, so I can get rid of C. Remember, when you circle that many, 8 out of 4, you're going to have one variable left, so it's D and we knot it. Okay, so that's one of them. Where's the other one? The other group.
Circle
Any
that
digit.
square 4 on the left
Yep.
side.
Yeah, so sometimes students will circle the 2. Remember, you can always share, so you got another group of 4. Remember, the more members we circle, the easier our expression is going to be when we have to actually work with it. So we want as big a group as possible. So if I move this way, looks like D is going to change and C is knotted. So get rid of this, put a bar over that. Excuse me, as I move up and down, looks like B stays the same, A drops out, and B's a 1. So we get B and not C. And looks like the only thing we have left is this one. And we can't share that with anything or anybody, so that's our last of the 3 groups. I'm moving this way, so I'm going to keep the value for A and C, but A and not B, but B is 0, so I got to knot that. Watch here, looks like D changes states, get rid of that. And I got A, not B, and C. So, at a certain point, you see how to play the game, and it gets kind of redundant once you see what's going on. But anybody ever heard of, in economics, there's something called the law of diminishing returns. Anybody ever heard of that? What does that mean, the law of diminishing returns? How would you explain that? The law of diminishing returns. It applies in economics, but it also applies in engineering. So what exactly does that mean? The law of diminishing returns.
It's like the more you do something, the less effective it is.
Yeah, some things, the more you do, what you get out, what you gain from doing it is not worth the extra effort that you put in. And after you get up, to me, in my opinion, after you get above, you can do this, and we can probably go up one more variable. We can go to a 5 variable K map. But the way to think about it's not easy. I don't even know if I really honestly want to get into this, because every time we add a dimension. So here we have now 2 planes. This is your normal 4x4. And so I'd have my A, my B, my C, and D there. But then you got these 2 levels here. You can add an E right here. And you can have an E right here. Of course, when you're on the top plane, when you're on this plane, E has a value of 0. And when you're on this plane, E has a value of 1. And so the way you put your members in there, when you look at it this way, it's a little hard to understand how you group them. And this is with 5 variables. If you go to 6 variables, then that's where that law of diminishing. I think anything over 5 is not worth the effort. And I question whether 5 is worth the effort. There's another way to do 5. I'll show you in just a second. But I think once you get above 5, then it's over. It's done. You'll let a computer do it. So we'll stop at 4. But I just thought I would show you this. Now, there's another way to express this. It's something called the overlay method. You can extend the map like that. And we can have 5 variables, which is helpful. But again, once you get above 5, it takes too long to do a problem. There's other things we got to do with the K-map, and it just becomes too cumbersome. So we're going to stop in this class at 4. And you'll be happy we stopped at 4 because your final exam is based on this kind of stuff. And by the way, there's a quiz, I think it's quiz 9. I'm going to activate that. Oh, wait a minute, today is just Wednesday. I forgot that well, I'll activate it. I was going to say, though, it's over this stuff. I'm going to give you a sheet that you actually download, and you'll do some of these K-maps, and then you'll upload it back to your Canvas, and I'll grade that. So if you can do what we've done on these 2 practice sheets, then I think you'll be in good shape for the quiz. Okay, so I don't think I want to talk about this 5x5. We'll get rid of that. We'll stick with 4x4s. And I don't have anything else prepared for the day. Anybody have any questions for me before we sign off? Questions or comments?
That overlay, was that just those 2 planes set side by side?
Yeah, kind of side by side. Well, they have it displayed a different way. Wait a minute, where did it go? Yes, they're kind of side by side, but you don't have to think about the groupings. I think if you do the overlay method, I think the groupings are this is a little more similar to what we just got through doing with the 4x4. I only showed you the 2-dimensional map because if we add a 6th one, now you're talking about a cube. And I want you to understand that, at least me, myself, I can't think beyond the 2 dimensions. I mean, I can't go beyond, I can't see the groupings, but there are people that work with me that can. So you can see how the numbers, how the count works. And it's a little easier for me to put the members here. And you can get the groupings and the values of A, B, C, D, and E. But if I think about this 2D map, you got to reflect the member down on both maps. And it's just kind of hard to think about how you would group them. But sometimes you group them in a plane, and sometimes your plane has to go down and grab the lower plane. So I don't even I showed you this because if we had other variables in our K-map structure, it just becomes so difficult. It gets cubic and it goes to weird geometries that I can't even begin to talk to you about. So yeah, so this overlay method is just another way to display that 2-dimensional map. I think it's easier to understand, but once you go to 6 variables, it's over. I mean, it's too hard. So we give it to a computer. Guys, that's all I have. Have a great rest of the day. Friday, we'll apply some of this stuff. You'll say, what the heck are we doing this for? Well, I'll show you partly of what we're doing on Friday with this. We'll connect this to a K-map, and we'll write expressions a certain kind of way. And then we can start using this for the PLC, and I'll show you how you apply this to a program, probably Monday of next week. We're getting towards the end of the semester. I mean, we have 2 more exams, but actually we have exam 2 coming up, which is a program, and we have exam 3, which is just a research assignment. You only have 1 more written exam, and that's exam 4, the final exam, which I want to give on the last day of the class, unless you guys decide otherwise. But I think I'm going to go ahead and activate exam 2 soon, because you've done half of it if you've done your last labs, so part of it is done. I'll display that, and you can start working on that. And I may just activate both exam 2 and 3, so that by the end of the semester you can have those done. Exam 2 will be due before the end of the semester. Exam 3 and 4 at the end of the semester. So I'll put them out there early so you can start working on them. And if you have any other questions, you can send me a text, not an email, but a text, and I'll respond to it. I'm here on campus all day today until night, so I might not respond right away, but I'll eventually get to it. So guys, you have a great rest of the day. And Aaron, are you still with me? Okay, great. Have a great rest of the day, and that's all I have. And I will see you guys on Friday.